Good day to you out there. Today we want to continue from where we stopped under the topic equilibrium of bodies in fluids. In the previous video, I have been able to explain the meaning of fluid and as well the forces acting on a body submerged in a fluid. Today, we want to quickly talk about density and relative density because they are related to the topic we are treating, which has to do with Archimedes' principle, which of course I stated in the last video. So we need to have proper understanding of the two quantities, density and relative density. As written on the board, density simply means mass over volume of a body. And the standard unit is kilogram per meter cube. Of course, it can also be expressed in gram per centimeter cube. But relative density shouldn't be mistaken for density. They are not the same. Relative density is the ratio of density of a body to the density of water, or ratio of mass of a body to the mass of equal volume of water. That is why I underlined this. You know, when I use density, I did not put equal volume of water. But when I use mass, or even if I use weight, I must mention equal volume of water. Why? Because the body must displace a fluid that its volume must be equal to its own volume. Of course, I stated this also in the last video. All right. Now, the next thing you are going to see on the board are the different ways in which we can write the formula for relative density. All right. Now, these are the different ways in which relative density formula can be expressed. The first part from here to here talks about relative density of a solid body. While here are meant for relative density of a liquid. So relative density of a liquid, we have to find the upthrust on an object in that liquid and also upthrust on that same object in water. Then we find the ratio. Same thing here, we find the volume of that liquid that we are looking for its relative density. You find the volume of that liquid that is displaced when we put an object in it. And also, we put that same object in water and we find the volume of water displaced by that same object. Then we find the ratio, it gives us the relative density of the liquid. So please, it's important you familiar yourself with all this. It will aid your proper understanding of every calculation we shall be dealing with under equilibrium of bodies in fluids, especially Archimedes' principle. Now, let's talk about principle of flotation. It states that a body floats in a fluid when the weight of the fluid that is displaced is equal to its own weight. So you can see this is different from Archimedes' principle. That means in this case, the weight of the fluid that is displaced, which is same thing as upthrust, will be equal to the weight of that body itself. That is one. Now, flotation can be seen in the following areas. When you have an inflated balloon and it floats in air, that means it goes up and is floating around in air. That is based on principle of flotation. The same thing, a ship that is sailing in water is able to float on the water due to the principle of flotation. And the factors that determine and that enable flotation are density of the object and the shape of the object. The density of the object must be less than the density of the fluid in which it floats. Please take note of that. Density of the object must be less than the density of the fluid in which it floats. If it is higher than the density of the fluid, it will sink. Please take note of that.